Hey guys, I just wanted to show you an example of a stoichiometry problem and work one for you. Hopefully this will help. Okay, so in this problem, we have a reaction in which nitrogen gas and hydrogen gas are combined together in a synthesis reaction to produce, this is ammonia, it's NH3. And then you may have a question where you would use stoichiometry, would be a question similar to this, in which it says, how many grams of the hydrogen are needed to produce 29 grams of ammonia. So in this situation, you know how much you want to produce, and you're trying to figure out how much of the hydrogen you need. So there's a lot of useful applications of stoichiometry because it's basically saying amounts in some part of an equation, and you're going to try to figure out an amount of another part of an equation. In this case, we're trying to figure out a certain amount of reactant needed to make a certain amount of product. Okay, we're going to use dimensional analysis to set this up. And so I'm going to first start with the given amount. Remember, in dimensional analysis, we have a certain given amount, and then we're going to try to get to a desired unit. All right, so I'll start with 29 grams, and I put the 29 grams because that's what I have in my problem here. And then I look for what I want. This is 29 grams of ammonia, and I want grams of hydrogen. Okay, yes, the unit is the same. I have both grams, but the stuff is different. So the unit's the same, but the substance I'm looking at is different. So that's why a conversion needs to be made. The first step of stoichiometry is actually not done right here. I have to back up. The first step is actually looking over here at the reaction, and I've got to balance this reaction. That's a very important step. So don't forget that step. I need to balance the reaction. Looking at this, I have 2 nitrogens on this side of the equation and 1 nitrogen here. So one thing I can do is put a coefficient of 2 so that 1 of these nitrogen molecules that has 2 nitrogen atoms in it can be used to make 2 of these NH3s. When I do that, I notice that on this side, now I have 6 hydrogens because each one of these compounds has 3 hydrogens, and if I have 2 of them, they have 6 altogether. But my starting material here only has 2, but if I had 3 of these, then that would mean 6 altogether, and then those 6 can be used to make what I have here in my products. Okay, so that should be balanced. Now on to the second step of stoichiometry. Did the first step, balancing it. The second step is that I mentioned that I'm going to go from grams of one substance in the reaction to grams of another substance. And I have to make a conversion. I cannot compare grams to grams here. I actually have to convert to something that I can compare. And what I can compare between these two things is moles. So I'm going to first convert this to moles. My second step in all of this process, but my first step right here is that I'm going to convert to moles. So I'm going to set up my conversion factor. And in my conversion factor, remember I want what I want to get rid of in the bottom, the unit I want to get rid of in the bottom, and then the unit that I want on top. So I want to get rid of grams, and I want to go to moles. I'm going to specify that this is NH3. And I have to think about the numbers here. So if I look at a periodic table, I know that 1 mole of nitrogen. So looking at a periodic table, I see that 1 mole of nitrogen is 14 grams, 14.01 grams. And hydrogen is 1 mole is 1 gram. I'm just going to round that to 1 gram. So back to this problem. In NH3, I have 1 mole of nitrogen and 3 moles of hydrogen. So that would mean 14 plus 3 times 1. And so my molar mass is 17 grams. This conversion means that in 1 mole of NH3, there are 17 grams. So I'm using this conversion to figure out how many moles there are in this amount. I'm going to continue on with my dimensional analysis. So I'm setting up another conversion. At this point, I'm going to use the mole ratio because I'm going to convert moles of NH3 to moles of H2. So I put the moles of the NH3 on bottom because that's one I want to get rid of, and then my moles of H2 on top. Now to think about what numbers go here, this conversion, I'm going to go back to my balanced equation, because in my balanced equation, it tells me the mole ratio as it relates to this reaction. And so I see that for every 3 moles of hydrogen, I produce 2 moles of NH3. So the mole ratio here is 3 to 2. Okay, so now my moles of NH3 cancel out, and now I'm left with moles of H2. And remember, my question says it wants grams of H2, so I'm going to do a conversion where I convert moles to mass. And remember, if I look at the periodic table, which I have here in front of me, that hydrogen, 1 mole of it is 1 gram. So in this hydrogen molecule, there are 2 atoms of hydrogen. So that means that 1 mole is 2 grams. Now my moles of hydrogen cancel out, and I'm left with grams of the hydrogen. And so at this point, I can stop setting up my conversions in the dimensional analysis and do some calculations. I'm going to take all the top and multiply it together, take all the bottom and multiply it together, and then divide the top by the bottom. So it'll be 29 times 1 times 3 times 2 divided by 17 times 2. Okay, and I get 5.1 grams of H2 is my answer. So let's talk about what that means. The question was, how many grams of hydrogen are needed to produce 29 grams of the ammonia? And so the answer is, if I wanted to make this much ammonia, I need to have this much hydrogen in order to make this. I also want to talk about some of these conversions that you're going to, and when you do these problems, you'll start with the amount that's given in the problem. So you'll start with that amount. And then the next step, if it's a mass, you're going to convert from mass to moles. Get this from the periodic table. You'll get this number from, or this conversion from the periodic table. The next you'll be converting from moles of one part of the equation to moles of another part of the equation. You'll get this number from the mole ratio, which you can find in the balanced, from the coefficients in the balanced equation. And then the next thing you're going to do is convert moles of the mole value that you found here, convert it to grams, and you'll find this from the periodic table. So the conversions are periodic table, mole ratio, periodic table. This is converting grams to moles, moles, and then moles to grams, and then doing dimensional analysis.